Hello guys, Mark at this side. So today we are going to solve today's GFG POTD, and the question name is sum of nodes on the longest path from root to leaf node. I hope you have already read the problem and at least tried by yourself. If not, I will strongly recommend you to at least give a read and try by yourself. So sum of nodes on the longest path from root to leaf node. It's a binary tree. That means it's very sure that every node has either 2 or 1 or 0. Binary tree. It's a binary tree. So find the sum of all nodes on the longest path from root to any leaf node. And if two or more paths compete for the longest path, then the path having maximum sum of nodes would be considered. So what it want to say, let us take the example here only. We have to look for paths from firstly root to leaf. Okay. And if a root to leaf path is called, which is covering all nodes from the path from root to leaf node. So here 6 is our leaf node, 3 is our leaf node, 2 is our leaf node, and 7 is our leaf node. So if I try making path, one path that will definitely would be 4 to 7. So let me write here 4 to 7. Another path would be 4 to 1 6 to leaf node from root to leaf. 4 5 2, 4 5 2, and 4 4 5 3. 4 5 3. The question says longest path from root to leaf. Longest, okay, longest path from root to leaf. So you can clearly see here are 4 nodes. So definitely this path is longer. This path is longer. This 4 2. This path of comparing 4 to 1 6 is a longer path. So we need to find the sum of this 4 to 1 6. So 6 1 7, 7 to 9, 9 4 30. So for this case, answer would be 30. Let's check here also. It's saying 30 and 4 to 1 6 because it is the longest path. Now coming to this case, here the number of paths would be one path would definitely 1 to 4. So let me write 1 2 4. Another path would definitely 1 to 5. 1 to 5. So we will write 1 to 5. Then the next path is definitely is 136 and 137. So I write 136, 137. Here it is difficult to distinguish that which path is longer because every path is of length 3. Every path is of length 3. So if I try adding them, 1 to 4, 6, it is 7, 5 to 7, it is 8, 6, 7, 8, 9, it is 10, 7, 8, 9, 10, it is 11. So I think the maximum we are getting is 11 and it is of this. Let's check the example. Yes, we are getting 11 of 137. So 2 points, like if there is a longest path, if there is a longer path, then definitely that longer path would be our answer. But if two or more paths are of longer, let's say longest path is of length 3 and more than one path is of length 3, more than one path R is of length 3, then we have to return the maximum sum, the maximum path of all those lengths. So here the maximum path, because all of them are of same length, so the maximum we can achieve is 11. So I think the problem statement is clear now. Let's come at how we will solve these type of problems and what's the intuition behind them. So simply, it's a tree problem. It's going to revolve around recursion. So now you will understand why recursion is important and why we need to master recursion. So let's say the intuition is clearly, let's say I'm at 5. Okay, I'm at 5. So 5 should be telling me, 5 should be telling me the longest path it has with himself till now. So if you ask 5, 5 will ask to his left, 5 will ask to his right. So from left it will get 2, from left it will get 2, and from right it will get 3. Surprising, it's not anything of surprise. We can clearly see 3 is larger. That means from right we are getting maximum. So from right we are getting. Now 5 also have to return his answer to someone above himself, that is its parent. So 5 will say, okay, for me, right one gives me the larger answer, that is 3. So now I will add myself my value also. 5 plus 3, 8. So for 4, the right value now is 8. For 4, the maximum right value is 8. I hope you are getting. So the clearly intuition is, at a particular node, we need to know somehow what is the maximum value from left, what is the maximum value from right, so that we can return our value plus maximum we are getting. So that's it. So let's say how we build this type of mindset, or how we actually think of it, how, let's say I'm at 4. I'm at 4. So definitely I would come a down recursive call. I would come at 7. From 7, we don't have any left and we don't have any right. That's means from 7, 7 left got reached as 0. 7 right got us 0. I think it's visible. Okay. 7 left got a 0. 7 right got a 0. 7 asked to its left, it got 0. From right also it gets 0. So both of them, it will say, okay, both of them are value same. So now for itself, the value would be 7 plus 0. That means now for 7, the recursive call is over. 7 will return actually 7 with himself. That is the maximum sum it is getting, 7. Now for right recursive call, we have 1. 1 has left also. Okay, let me erase now, erase these stuff, because we have already get the answer. Okay, so for 2, it will go right. For 1, again left exists. Now for 6, no left exists, no right exists. So for 6, it's getting 0, it's getting 0. So 6 will say the maximum I can return is 6 plus 0, is 6 plus 0, and that means it's 6 plus 0. From here, it returns 6 plus 0, which is 6 only. Okay, it returns 6. So now 1 will go to its right. For 1, we have a 0. So 1 will say, from left I am getting 0, from right I am getting 6, the maximum is 6. So if I have to return, I will take this 6 with me. So 6. So we have 6 with ourselves. Now 1 will add a value with himself. So we will get actually 7. We will get 7. I hope it is clearly visible. 7. So the question is now simple down to the 2. 2 is getting 7 from its left. 2 is getting 7 from its right. Clear. Okay. So now we are getting 7 and 7. For 7, now 2 will ask, what is the maximum value? We will clearly see both are same. So 2 will say, I can take any of them, but and I will return 9 from myself. Why 9? 2 plus 7, 9. So for 4, now for 4, the left value we know is 9. For 4, the left value we know is 9. Now, similarly, for this entire recursive traversal has been done. It will now come to right. 5 will come to left. 2 will come to left. 2 will come to right. 2 will find 0. 2 will find 0. So 2 will return 2 to here. 2 will return 2 to here. Now, 5 has done for its left. 5 will go to right. 3. 3 left. 3 right will get 0. 3 will return himself with 3. So it's now the scenario is like 5. 5 is getting 2 from its left, 3 from its right. The maximum is 3. 5 will try to take this sum. So 5 will return 8. 8. So now 4. For now 4, I have also have the right value, that is 8. 4 will say, 4 will see what is the maximum value I can perform. It is getting 9 from the left, 8 from the right. So 4 will say, okay, 9 plus 4 gives me 13, so I will give 13. So 13 is the maximum sum we are getting. 13 is the maximum sum we are getting. Okay. So this is how like we are actually trying to form a recursion, and like we try to go down, and while returning back, we tend to get the maximum answer we have. So for 5, 5 explode till down, but while returning, 5 get the maximum from left or right, and by getting that left and right, 5 forms its answer and return its value. So this is something. So this is the entire intuition. I'm at a particular node. I'm a particular node. I should be knowing what is the maximum I'm getting from left, the maximum I'm getting from right, and the answer would be my value. Answer would be my value plus the maximum I am getting from left comma right. This is clear, okay? But now, does this simple thing will help us solve this problem? Eventually, this will solve. This will help us, but not in all cases. Why? Because we are also given. We are also given. Let's come to the question. A longest path from root to leaf node. So here we can clearly see, yes, this is the longest path. This is the longest path. So there is no worry. There is no worry. What if this value, so from here we are actually getting 4, 5, 6, 7, 13. And from here 5, 4, 9, 12. Let's say this was 8. Let's say this was 8. So from here 8, 5, 13, 13, 4, 17. We would have got 17. 17 is not the answer because we have to look for the maximum path. So that's why we don't only need to maximize the sum, but we also have to look what is the longest path? Till now, what was the longest path? Till now, when I was at 5, I was asking, tell me your left value, tell me your right value, and I will try to form the maximum answer I can form using my value plus left or right. Okay, but this is not the case every time because we need to find the longest path. So 5, instead of like 5 will ask what the maximum value you have with left or right. Also, 5 will ask what is the maximum length you have no for left. What is the maximum length of nodes you have and what is the maximum length of nodes you have length. So here for 5 it has one length. 5 has one length with 5 has three sum with one length, 5 right, and 5 left has two sum with one length. Now, since both lengths are same, so now it will look for sum. Now it will look for sum and it has. So at a particular node, we are not only asking the maximum value you are getting from left or right. We are not only interested in getting the maximum value from left or right. Also, we are interested in what is the maximum level of length you have covered from left and from right. If left length is greater, then no matter I am getting some lower or higher, I will always take consideration to the longest length I am getting. So let's do the dry run by this only. The same example, I will like equally. This is the same thing. You can dry run by on your own, or let me take very simply one. So like one will came here two from four it 0 0 0 0, so it will return four. For five also 0 0, it will return five. For five this one is maximum, so it will return seven. 1 3 6 7 6 for 6 it is 0, it will return 6. For 7 also it is 0, it will return 7. For 3 7 10 is maximum because from here it will get 9. And now for 1 we have 7 from left, 10 from right, ultimately 11. So this is okay. But now we also need to know the length. So for this, instead of getting only the maximum length we are getting, this time we will get like a pair of length or the value we are getting. Okay, the value and length. So we will do the same steps. Let's say I'm at 4, I come to 2, I come to 7. 7 left, 7 right. Okay, let me make this image bigger, more bigger. Yes. Okay, we came to 7. So now here we came to 7, left 0. From left it will get 0, 0. 0, 0 will return because 0 length. There is no more length from 0, 0. So from 7 we got 0, 0, 0 0. This is the sum we are getting and this is the length we are getting. So 7 will return nothing but 0 0. So for 7, when 7 has to return, this time 7 would have one length 1. So 7 will return 7 and with length 1. 7 and with length 1 because 7, this node, this would be a one length because 2's left would be like this is one length. Okay. Similarly, for 7 1 we know. Let me erase this stuff. And from here, now it comes to 2 and it will come to 6. 6 left, 6 right. Okay. So from here, for 6, things will be same 0 0 0 0. So 6 will return from here 6 comma 1. Why 1? 1 would be the length of this path and 6 is the maximum sum it has. So let me erase all this so that it doesn't become any confusion. So from here we got 6 and 1. So now for 1, for 1 from left we are getting 6 1, but if I try to explore 1's right we will get 0 0. So you can clearly see this length is maximum, this length is maximum. So that's why my 1 will say okay, I will return this length because this length will now give me length 2 and sum will be 7, 7 comma 2, 7 comma 2. Why? 6 1 7 and this is a longer length. So from here now I have 7 comma 2. So things have become easier for now. Now let's see. I'm at 2. 2 is left is same. I'm with 7 but with length 1. From my also right, I have also 7 but with length 2. So I will consider maximum length. Though sum is also same. but I had to consider maximum length, which is 2. It will take 2, and since length is taken 2, it will take this sum 7 to 9, and now plus 1, because this length also count, and it will become 9 comma 3. 9 comma 3. Okay, getting. So from left it is explored. Now we know for left that for this left we are getting maximum 9 comma 3. It will come to 5, it will come to 2, it will come to 3. 2 will say 0 0 0 0. So it will return from here. We will get, when we will return to it's to 5, we will actually get 2 comma 1. We will actually get 2 comma 1. 2 is the maximum sum, 1 is the length. So 5 will explode to its right. From 3 also we will get 3 and 1 length. Now 5 has both 1 1 length, but the maximum is 3. So 5 will say, okay, since the length is same, so it's better for me to take the maximum path sum. So it will say, okay, I have 8 with length 2. Why length 2? Because now this will also include. This is 1 length, 2 length. So let's erase all these things. Let's erase all these things. We have 8 2 from here, we have 9 3 from here. 4, we have 9 3 from here, and we have 8 comma 2 from here. Honestly, we can clearly see 3 is the maximum path, although sum is also greater. But even if, like 4, we have 9 comma 3, and here we have 8 comma 2. If we have 5 also here, we would have preferred this path because length is greater. Okay, so don't be confused. So simply from here we are getting 9 with length 3, and from here we are getting 8 with length 2. So now when I return to back, 4 will say 13 with length 4, because now this path will also come down. So not not like this, like 1 2 3. So 4 will say, from here I'm getting 3. I'm getting 3. So for 4 the answer would be 13. And if I took here for this, the answer would be, for this the answer would be 8, sorry, where we are at 8 12. So maximum is 13, because now we have come to root, and since we are at root there is no other node, so 13, and 13 is the maximum we are getting. So this is how we try to formulate the previous solution where we are looking for maximum sum. But since we also have to look what is the maximum height also, like you can say height, you can say maximum length, because if there is length 3 and there is length 2, I will always prefer length 3. So this is only. Now see how we will actually tackle this problem. Let me delete this example, and now let's minimize this, and I have put the code here only. Let's erase all this. So okay, I hope this is visible. So this is actually, first of all, this is nothing but, I said I call a function with helper, or I pass my root, and this is, let's say, current sum. That is current length, that is 0 only, because at root we have 0. Here we got 3, here we got 2. Okay, for 4 left would be 3, but at current if I am at 4, I have 0 only, so we pass 0 here. Okay, I think there should be not any doubt in this. Now let's say here the base case, simply the base case. Let's say I am at 6. I am at 6. I came to 6 left. I came to 6 left. So from 6, I know 0 0. So we return 0 0. 6 right, we got 0 0. No big deal. Okay. I am having a pair of left, pair of right. Why? Because if I'm at 5, I should be knowing what value comes from left, what value comes from right. And since we are returning a pair, 5 should have its own pair. And in this case, 5 would have a pair of sum 2 with length 1, and it has a pair of 3 with length 1. So this is, so what I did, I say go to left, go to your right. So 4 will go to left, 4 will go to, simply a clear recursion, 4 will go to left. So it will left. So again, next time it will be at 2. Again, this function again recursively call 7, it will go to left. And since the base case will hit, it will get 0 0 from here. From left, it will get 0 0. Okay. So now this base case is in, so this statement is completed. From right, it will go to its right, and it again got 0 0. So left got 0 0, right got 0 0. Okay. Now see, left second, right second. This is second part. This is actually length. You can see not a, both are zero. Both are zero. So that means we are not getting from like left is not maximum, right is not maximum. So we will look the maximum we are getting. We will look for the maximum we are getting. And if you clearly see, the maximum we would be getting is left value, right value. First value, both have 0, 0. So 0 plus left 0 plus 7, because 7 is the roots value. So it was 0, it was 0. So max was 0. 0 plus 7 is 7. So we return 7 from here, but now the length will become 1. Now the length will become 1. So we return left dot second plus 1. And even if we have written right dot second plus 1, both are same, because at this point both heights are same. So this how we have maintained 7. Okay. Now let me do some sort of things earlier only. So from here we know we have 7 and we know we have 1. When it's come to 1, 6, we know from 6 also similarly this thing will happen. From here we get 0, 0. But well, I will back, it will be 6 and 1. 6 and 1. Okay. Now for 1, for 1, the left part. For 1, the left part is 6, 1 and right part is 0, 0. So here we will see the left second part is greater, sorry. Left second part is greater. So I will return, okay, tell me the sum with you. It has 6. It has 6 with himself and the root value is 1. 1 plus 6. So it will return 7. It will return 7 and left dot second plus 1, because left was greater than and it was already 1. So it will return 7 comma 2. It will return 7 comma 2 because one path, this path, two path. Okay. I think this is done. This is done. Okay. Now for 2, for 2, I have answer for here also 7 comma 1. I have answer for here also 7 comma 2. 7 comma 1, 7 comma 2. Now 2 will say left dot second greater than right dot second. We can say no, left dot second is not greater because left dot second is 1. Right dot second is actually 2. So this part will be run, because this time left dot second value is less than. So similarly, root data plus right first. Right first was 7 and root data was 2. So we got 9. And since we have path 2, we return plus 1. So 3. 9, 3. So from here, we definitely got 9 and 3. Similarly, from here also, the maximum we can get is 8 comma 2. But uh, for 4 also, the maximum we can get is 8 comma 2. And when we get this 8 comma 2, when we get this 8 comma 2, we can clearly see this time left dot second value is greater, because from left we are getting 9 comma 3 and from right we are getting 8 comma 2. We can clearly see this is greater. So I will say return root data, that was 4 plus left first, because that means we have to take this 4 plus 9 would be 13, and we will return left dot second plus 1. It was 3, so it will become 4, but 13. And this is actually done. This is done because that's what the last recursive call. And this was the last recursive call, and 13, we would be done with that, because we know what is left, we know what is right, the answer is formed. And since this was the very first recursive call when we started from root with sum 0, so we got 13. We got 13, and you might be thinking that we got 13 4 from here, but it's actually the case when, what if we have, let's say, 8 here. So for 8, for this 8, the value would be 13 comma 4. But since we don't have, so we are interested on 13. So we got 13 and 13 would be the answer. This was the last recursive call. If someone who is not familiar with recursion might be having some doubt that how we get 13. When I started from this 4 only. This 4 only. So actually the recursive call for this 4 returned me 9 comma 3, and for this returned me 8 comma 2. For this 4, the left got all, the right got all. So since the recursive call was started from 4th, the maximum value for 4th I got is 13 comma 4, and now 13 would be written by this whole function. And if you come to down, I am saying, okay, give me root first. Now my roots first contain 13 and 4, and I'm asking first value. So 13 would be the answer. So I hope I was able to explain you the problem. This is nothing but a trivial recursion. If you are having a difficulty with this, solve problems like path sum, maximum path sum 2. They all are pretty similar problems. The way we traverse tree. Here, I am asking 5. Tell me the maximum sum you have from your left or right. This was actually in path sum. But here there is one more additional factor, that what is the maximum length I am getting. Because if the length from left is higher than the length from right, then I would going to take from left. That's why we have to maintain two values. That is the maximum sum I am getting and the maximum height, you can say, or you can say the maximum length I am getting. This length has more dominating factor, because the higher the length, I will take that path only, because the question itself says maximum length, sum of nodes on the longest path from root to leaf. Okay, and if that's not the case, because this was the exact same statement. If that was not the case, if both are yielding the same height, then we will look for the maximum of left comma right. So this is all about the problem, and this is the code is working completely fine. Solve question like path sum. This will generally help you to build skills, some set of concept clarity on recursion, and path sum 2 also. I don't remember path sum 2. This is a simple one. This is a backtracking one, I think, where you need to store all the paths in a vector. You will find both the problems on lead code. You can also find it on GFG. But the point is, you need to be clear enough that path sum tell me the maximum path from left or right. In this question, we are also concerned about height. Okay, tell me the maximum. Okay, I know the maximum path, but I am telling the maximum height from left or right. I am going to take the maximum length or height. Whatever you get from your left, whatever you get from my right, I want maximum. So that's it from my side. I hope you're able to understand this problem statement, and now you can able to apply this concept in coming problems. So that's all, and now get this side. Thank you.